Here we have example 2, which says use quantifiers to make each of the following true, where n is a natural number. Now don't forget that, and I know this has been a long time ago, but we usually use n for natural numbers, w for whole numbers, z's for integers. I don't know if you remember back that far, but whenever we introduced the number system to you, there was very specific symbols that we used for the number systems. So they're just saying n is a natural number. Now, that means you got to remember what a natural number is. A natural number is also called a counting number, and those start with 1 and go up. It's like whenever you're a little kid and you start learning how to count. You're sitting in front of Sesame Street and at the in the TV and counting 1, 2, 3, 4, 5. That's the natural numbers. Whole numbers are where you add 0 to that list. Then those become the whole numbers. So I hope that you remember that distinction. Anyway, back to this. Use quantifiers to make each of the following true where n is a natural number. Now what they mean is they want us to kind of write out a sentence that makes sense if this is a true statement. So for part A, we have n plus 8 equals 11. And we know that we could come up with a number to replace n with that would make that statement true, right? So what we're going to do is we're going to write there exists a natural number n such that n plus 8 equals 11. That's what we're talking about when we say use quantifiers to make each of the following true. I mean, n plus 8 equals 11 is true if only on the condition that there exists a natural number n such that n plus 8 equals 11. Now what about this statement here, n plus 3 equals 3 plus n? I don't know if you remember or not, but this was the definition of the commutative property of addition. So, in fact, it doesn't matter what you use as n. This is always going to be a true statement. So, for all natural numbers, n plus 3 equals 3 plus n for every single one of those.